Okay, thank you for joining me for today's Lunch and Learn. My name is Dan Hotka. I will be your host today. And let's just make sure that the audio is working good. We have a good turnout. I want to thank you very much for attending these. I appreciate your patronage. A short thing, part of my agreement. And I am an Oracle ACE Director. We are outside recognized experts by Oracle Corp. Our goal is to share technologies among the masses. I honestly like this media of doing these Monday Lunch and Learns, these short lectures to share my knowledge with the masses. If you would like to become an ACE, I believe there's more than 500 of us now. If you would like to become an ACE, go out to the Oracle.com website. You can just search on Oracle ACE, fill out the template. If you would like my help, please reach out and let me know. I'm up to 14 books. I'll have 2 more books out yet this year. Several of you, many of you, have registered to get the Lunch and Learn links on Monday mornings. Anything else I've got going on, I'll make announcements too. But everything is conveniently out on my website, along with these recordings and the slides. Today's presentation won't have many slides, but it'll be available if you would like to download it. I do regularly blog, and I do regularly do training on-site, over the web. On-site, I do have my own portable computer lab. I worked off of a fixed fee type of a price. You can review my courses. You can go out to my website and review my courses as well. Let me know when you have a training need. Let me help. Thank you very much. I've been working on this BMW Isetta. This is a 1957 BMW Isetta. I kind of stumbled across it. You know, many of you know that I have a Volkswagen fleet, and I like working on my Volkswagens. But we reunited the body with the chassis. This was part of the party last fall of putting it back together. And I'll be working on this car. I'm still tinkering on it. It's not quite running yet, but soon. I'll have it running soon. And hopefully we'll have it completely together by next spring. Okay, this is Explain Plan Month. I'm going to talk about, today I'm going to talk about the Oracle architecture and how it applies to the Explain Plan process. The links to this presentation and the recording will be available after this presentation today at www.danhotka.com. Okay, today's topic is the Oracle architecture from a SQL tuning point of view. Okay, I'm going to go through the hard parse process and basically the different pieces that affect SQL statement tuning from an architecture point of view. Okay, this material is excerpts from my SQL Tuning for Developers course. All right, there's the slide. Out here we have the internet. This dotted line here kind of denotes the internet. Okay, and we have our end user workstation base out here. We have on the server that you're connected to, we have the listener, of course, the Oracle processes, the background processes, and the memory structures. We're mostly going to talk about the memory structures today. Everybody, when they get connected to the database, either gets a shared background process. We'll go with the dedicated background process because that's what most people are set up to do. They really work about the same. Everybody gets their own program global area. There's lots of things in this program global area. I cover most of them in the tuning class and the PL/SQL classes. The one that's important here is the SQL cursor area. Okay, SQL cursor area is where the row set, the final row set after Oracle's done processing your SQL statement, that's where the row sets are processed. So basically it works like this. You submit either a PL/SQL block or a SQL statement through SQLnet, through your application, through your background process. Oracle, if it's a PL/SQL block, it'll start executing it. If it runs into a SQL statement, tosses it over to the SQL engine. Okay. If it's a SQL statement, it just tosses it to the SQL engine. and that SQL engine tosses it up to Oracle. Okay? From here, Oracle will process your explain plan, okay, which is a series of processing these row sets. And when it gets to the final row set, okay, this is then returned to your program global area. Your application is woken up and said, hey, you got some rows back. And then now it's however your PL SQL is programmed. And in the advanced PL SQL class, I talk about several options on getting these rows back rapidly, one at a time, but more rapidly. Okay, so the rows are returned. Life is good. When the SQL statement goes up, either via PL SQL or SQL, by the way, this is called a context switch. When you have a SQL statement and a PL SQL block and it gets tossed over, and that does take a little bit of time, and you'll hear us experts talk about the context engine switch. Okay? At any rate, today we're talking about hard parsing, soft parsing, and processing the SQL statement from an architecture point of view. The SQL statement's tossed up to the library cache. The library cache is nothing but a great big hash table. It used to work differently, but in today's Oracle, it's a great big hash table. When I talk about hashing, basically you take the key value, multiply some math to it, and it comes up with a unique location, whatever that unique location is. Whenever you put the backwards through the math, you get the same key data, okay? The library cache, what it does, and Oracle, by the way, uses hashing a lot. It uses it as part of a join condition. Almost all these memory structures are hashed, perhaps. The library cache definitely is hashed. So what happens here is the SQL statement goes up to the library cache. And notice there's a dictionary cache for the dictionary SQL. We'll get to this in a moment. Those are the SQL statements that run the Oracle processes, the dictionary itself. Okay? So, what Oracle does is Oracle's very interested in doing a soft parse. A soft parse is when it already has an execution plan and it's just ready to execute. When a SQL statement executes, now it's interested, are my rows in the buffer cache, or do I need to go out to the table spaces and get them, i.e. logical reads versus physical reads. All right? And then we'll get to these other things in a moment. So, when the SQL statement gets tossed up to the library cache, Oracle does a checksum on it. Does a checksum on that SQL statement, and then it hashes that checksum value, looks it up in the library cache. Have I seen the SQL statement today? More importantly, have I seen the SQL statement since I last ran statistics? Because the library cache is generally big enough now to hold all the SQL statements for execution since the last time statistics were run, and at statistics time is when it gets purged out, i.e. you have new statistics. The statistics are really only used at hard parse time. It's a lot of work to hard parse. So that's why Oracle likes to make sure on a soft parse, do I already have the SQL statement and do I have an explain plan for it? Okay? There's a couple of views. $SQL gives you a lot of information about the library cache. It's called the parent cursor, a view into the parent cursor. $SQL area is the child cursor. It actually contains the explain plan, okay, and some more statistics and runtime stuff and other things like that. When you run statistics, it's that child cursor that gets stepped on, so that Oracle has to re-hard parse. If there's no explain plan, Oracle will hard parse. Soft parse, it's all ready to go, pretty quick process. Now we're going to talk about hard parsing. When Oracle doesn't have an entry in the library cache or there's no explain plan. All right? No explain plan. So, hard parse time, Oracle's going to start running dictionary SQL on your behalf. It runs 4 of them. Maybe more, but I'm aware of 4 of them. The first one is permissions. It's a permissions check. Do you have permissions to the objects that you're trying to access with your SQL statement? The second one is it's going to start looking up your table names and columns to make sure you've spelled everything correctly. This is a very important step because this is the one where it starts pulling in all the statistics that are available. If you have indexes, there's index statistics. It pulls in a variety of statistics. We might do another lunch and learn just on statistics, okay, and what gets collected. At any rate, the third SQL statement is actually an insert statement. Oracle saves all of the where clause predicates. A where clause predicate is the column in the where clause that relates back to a table. That's what Oracle calls a where clause predicate, okay? It saves all of those because there's an option at running statistics where Oracle can run histograms on all of the where clause predicates. So it saves all those. The fourth one, I believe, is an insert statement into the AWR, Automated Workload Repository. Showed up in Oracle 10, and what Oracle's doing is it's going to keep track of the execution plans, it's going to keep track of runtimes, it's going to keep track of a variety of information for your SQL statement for 7 days. In my advanced SQL tuning class, we talk about how useful that information is. Okay? So anyway, the next thing that it does is it does what's called a query transformation, okay, which is a subtle rewrite, sometimes a major rewrite. We're going to talk about query transformation, and the next step, which is permutations, which is the loop-de-loop that Oracle does, trying all the different cost numbers, okay? And when it comes out of this, it then produces an explain plan. The permutation process is kind of interesting. What Oracle's doing here is it's looking for the lowest overall cost of a query. And when it does this, it doesn't exactly know. It's got statistics, it's got math, and it's got educated guesses as to what are the row counts associated with each line of the explain plan. Oracle goes with the lowest cost. Cost is roughly, but not exactly, physical I/O. Okay? Don't quote me that it's physical I/O. It's based on physical I/O, and Oracle's looking for the SQL statement to run an explain plan on, the version, the combination of your where clause items, your indexes, and your table joins when you got multiple table SQL statements. What is the proper order? Oracle has to pick one over the other. I kind of call this brute force, and again, I'm going to talk about this next week's Lunch and Learn, what goes into this permutation process, because it can be quite intrusive, and that's the main reason Oracle doesn't want to hard parse any longer than it has to. It's CPU time, it takes time to do this, and it can be fraught with error. That's where we get performance issues. So, okay? So, you got a SQL statement, so that's how it comes up with an explain plan, okay? Oracle 11 processed bind variables a little differently than Oracle 10 and 9. Oracle 8i and before assumed even data distribution when you had a bind variable in a SQL statement. Oracle 9 and 10 peaked once at the bind variables, okay? This was good as long as the data was fairly even across the structure, okay? Let's use a name lookup. And I always like to compare my name, Hotka, to Smith and Jones. Lots of Smith and Jones, few Hotkas. So when you if the first one in on an Oracle 10 database, the first one in, Monday morning, stats are run on a Sunday, the library cache is flushed out. First lookup on that name app on Monday morning is a Hotka. Oracle process sees it has an index, sees its low granularity, lots of good things happen, puts together an explain plan to use the index. And when you look up a Hotka or low row count type names, it's going to use an index. It's going to be pretty efficient. When a Jones comes along, that will perform poorly because doing single block reads off an index over a large part of the structure isn't efficient. Oracle wants to do a full table scan on Smiths and Jones because they make up a large part of the structure, perhaps. Let's just go with the fact that they do. Okay, so that was a problem. Oracle 11 introduced this thing called adaptive cursor sharing. You have to have a histogram on the bind variable column from the database table, whatever the bind variable is being compared to. And what Oracle will do is it peeks at the bind variables like it did in 9 and 10 and comes up with an explain plan. If there is a poor execution, this is where AWR comes in and starts benefiting Oracle. Oracle will compare the runtime to the prior runtime and notice, hey, this one was significantly off. So it has to perform poorly once. Okay? It will go out to the histogram and see if the row count on that part of the explain plan is significantly different. And if it is, it will re-hard parse that, come up with another entry in the library cache for the child table, and keep track of those. It'll do this up to 5 for 5 different SQL statements. Okay? So adaptive cursor sharing is good. Oracle 12 has picked up on the sharing of information, sharing of that bind variable information and sharing of those cursors. Remember last week, the folks that had tuned in last week, the ones of you who haven't, go out to my website and look at the replay for last week. What I talked about was various explain plan syntax. And part of that syntax was getting the actual row counts for a SQL statement when it executed. Oracle 10 and 11, they all saved it. Oracle 12 is going to start making use of that. After a SQL statement executes once, Oracle has actual row counts. Okay? And what it's going to do is it's going to save those actual row counts, those where clause items, particularly the tables and the table joins. It's going to save the row counts associated with that. Let's call them SQL directives, and they're going to be used at hard parse time to influence and make better running SQL statements with current statistics. The biggest problem I see when I go on site and help people with tuning issues, by the way, I am available for consulting, although I prefer the tuning. The biggest problem I see is accessing current data when stats were run on Sunday. It's Tuesday, it's Wednesday, it's Thursday. The stats are starting to get pretty obsolete. And Oracle, if you take the tuning class, for those of you who have taken the tuning class, thank you very much. You know I talked about what Oracle does when it makes guesses. You know, it makes poor guesses. And when the math gets wrong in an explain plan, it just gets worse as it goes up the explain plan tree. It's not a self-correcting type of a process. So this is key. Oracle's going to save this information and reuse it, and it will help with better statistics when you get to Oracle 12. Some of these problems should just go away. The last thing that I wanted to talk about today deals with functions. You got my function, and it could be get state name, and you're passing in a state name, okay? And what this will do, pass in Iowa, and it returns Iowa. I happen to live in the great state of Iowa, okay? So you run my function, pass in a state code, returns Iowa. You're doing this all the time from a number of places in your application. Inside here is a select statement, goes out and looks this up, brings back the information. You know, it's kind of nice. You don't have to store the full name. The states don't change much, blah, blah, blah. Oracle 8i through 10G created this thing called deterministic, okay? Deterministic, you compile this clause. Look it up in the syntax, in the documentation. Deterministic says, if you run the same function with the same invariable, I'm going to save the last time it executed. And I'll just pass you Iowa because I already have the last time that it executed. And this is great. Oracle 11 and 12 has this too, picked up on this and came up with this result cache. Not only does it save the last time you ran it, it saves all the time you ran it. And for the object owner, it saves all of the results. So it's a cross-user session. So it's better, sleeker, and it works very well. It will save all of the results. It'll save Iowa, Missouri, Seattle, Colorado, all of them. It'll save all of them. It gets reset if someone makes a change to the table. So it works better on tables that don't have a lot of changes to them. You know, tax codes don't have a lot of changes to them. The state of Iowa, has 99 counties. Those haven't changed since the 1860s. The United States hasn't added a state since 1961. There's a lot of things that are pretty stable. The other thing to keep in mind is this function cannot be affected by anything else. You submit this, you always get the same answer. It is not influenced by any outside things such as date, timestamp, or anything else, any other environmental settings. This will work great for you. It'll save executions of your function, particularly those that are making repeated calls to things. Okay, we talked about a number of things today that dealt with the Oracle database and how it processes SQL, how it does hard parse, how it does soft parse. What's the difference there? Okay, we talked a little bit about what we're going to talk about next week, the permutation, the hard parse process. But I also shared with you some key memory structures, like the result cache, the adaptive cursor sharing, and the SQL directives. The links and slides to this presentation are going to be available on my website shortly. Tell everybody about these. I want to thank you for your participation, and do remember me when you have a training need.